Welcome to a lesson with Dr. Powell. In this video, we will look at a practice problem that deals with using the intermediate value theorem. Suppose that we have an equation and we want to verify that it has a solution for positive values of x. How in the world can we use the intermediate value theorem for that? When you're ready to try this out, work on it. So pause the video, work on it, and then you can play it to see the solution. On your mark, get set, pause the video. Okay, now here is the solution on this one. Okay, so what we're going to do is I'm going to think of a function sine of x minus x squared. All right, and kind of the idea is that if I can show that for x is greater than 0, that for x is greater than 0, that somewhere for some x value, this function is hitting some kind of like some negative number, and then for another value, it's hitting some positive number, then the intermediate value theorem says that if f of x is continuous, which it is, you're adding or subtracting whatever composing stuff with continuous functions. Here, this is going to be continuous. So intermediate value theorem states that any line that I can draw between these two lines, y equals positive, y equals negative, including y equals 0, must be hit by the function. So you know there will be a solution. In fact, the solution will be between those two x values. That's what the intermediate value theorem states. So to verify this has a solution basically amounts to plugging in finding x values that we can just randomly throwing x values in until we see one that's an output that's negative and an output that's positive, as long for x values that are bigger than 0. I'm going to throw in pi 6 into this. Okay, so sine of pi 6 minus pi 6, pi 6 squared. Now, in this particular case, let's think sine of pi 6 is 1/2, and this is minus pi squared over 36. So it's kind of like 9. It's like 9 over 36. It's like a fourth, or something like that. So it's going to be less than 1/2. So this is going to be positive. So it looks like that f of pi 6 is actually a positive number. Now let's try something else. What if we just did something like pi? Okay, so if we plug in pi, notice that the sine of pi is 0. Sine of pi is 0 minus pi squared. Hey, that's going to be a negative number. That's going to be negative pi squared, which I know is negative, which means f of pi is negative. Well, we have somewhere we're above and below. And so in this particular situation, it looks like we're going to be, so this is just a description of what the intermediate value theorem is, but in our particular case, it looks like we're going to be going downhill with that instead. Okay, because, we're trying to see where, right, because where this is equal to 0, just as a refresher, is where we're going to have a solution there. Okay, so as we're going downhill here with our function, so at pi 6, we're hitting something positive, but at pi, we're hitting something negative, so there must be a solution between there. So I know there must be a solution between pi 6 and pi. Okay, so there is a solution somewhere in there just by using that little idea, because we plug something in, got something positive, something negative, so in between it must be 0 at some point. So, I mean, thinking of positives and negatives and zeros is kind of a nice thing to do. That's why I rewrote this as something where I have 0 on one side. Notice that, so that I can be comparing to 0 between positives and negatives for the intermediate value theorem. So that concludes that little practice problem. And thanks for watching.